Hello, my friends. It is Rich Whitehouse, and I haven't done a video in a while now, I guess, because I've just been in complete medical hell this year. Um, I've had a strep infection in my ears and throats that's been going on for over 3 weeks now, not responding to a couple different antibiotics, so they're in the middle of uh, doing blood culture for that to see if they can find a way to tailor a custom antibiotic treatment for me, which seems like a load of bullshit because I know that strep cultures or blood cultures for strep often come back with false negatives, so I don't know. I don't care. I'm just letting people stab me and hoping I'll get better at some point. Um, but anyway, while I wait for death, I've been working on BigPEmu in whatever limited capacity that I can, and I posted the full situation with my medical stuff on my Patreon account not too long ago, and I had a nice response. A lot of you upped your pledges, and I had some first time people sign up too, so I really appreciate that. Thank you. Like the only work that I can actually accept at this point is like small cracking jobs where it's basically like I'm already so much better at the work than everybody else in the world that it doesn't matter if it takes me a week because I can only work one day of that week or whatever because it would take most people a month. So at beginning small, I think I've gotten like $5,000 so far this year from small jobs like that, um, which is obviously not enough to sustain me. But I can't do production timeline type stuff at this point. And hopefully that changes. But honestly, I don't, I think I'd be an idiot to still have hope at this point. And mind you, despite being hopeless, I'm proceeding under the possibility that good things could still happen. Obviously, I haven't killed myself, so I'm not, I'm not excluding the possibility that things might get better for me. I just don't really have hope anymore. But um, anyway, so that wonderful intro out of the way. I'm releasing my first public BigPEmu release in a while here. That's got some pretty big new features. So I figured I'd do a video. And the real substance of this video is actually going to be demonstrating some of the new Blitter capture stuff. So mostly people who aren't developers or don't have interest in how the games are functioning under the hood aren't going to get a lot from this video other than just me talking and listing off a few features that you could just as easily read from a bullet list. But, but anyway, um, so those of you who are not too cheap to cough up $10 have had access to most of these features for a month and a half already. Because I released, the first Linux build and everything to my Patreon supporters about a month and a half ago. There are still some new things in this release that I've kind of like chipped away on in the last month and a half as well that were not included in that Patreon build. So there is some brand new stuff in here for everybody too, which I like to kind of mix it up like that. Like give the Patreon subscribers um, exclusive stuff for a while and be like, hey, if you don't want to pay $10, I don't really give a shit. Like if you actually want that Linux port, pay $10 for it, buddy. I mean, what the hell? But anyway, so I like to do that. But then for the next public release, I've usually still managed to do some extra stuff at that point, and then the Patreon subscribers still get to enjoy the public build as well. So everybody's happy. Um, but yes. So obviously, there's a new Linux port for this version of BigPEmu, which also comes along with an SDL2 plugin, which functions for all of video input and audio. So that's an alternative. Maybe if you've been having problems with the direct input plugin for whatever reason, you can try the SDL2 plugin. And a nice thing about that is also that you can swap out your SDL2 DLL or SO, as the case may be, implementations, try different versions that work with different native APIs and set different environment variables and stuff like that. So you've got a lot more wiggle room if you are having problems with any platform implementations. So even for Windows, it's kind of nice to have that option, even though for the most part, I don't think anybody will have a reason to use SDL2 for video, audio, or input, really, but it's there. And of course, it was mainly for the Linux port because I'm like, I don't really want to deal with any of these Linux platform layers, and the desktop and windowing situation there is revolting to say the least. So, so I figured, yeah, let's let STL2 handle these things for us. Um, but anyway, there is also a new Windows ARM64 port, and that's a new thing that I've been chipping away on the last month and a half or so, gradually. It also comes with a D3D12 video plugin, which again is also offered for just the regular Windows x64 builds now. And that's at full feature parity with the OpenGL plugin. Um, I've crafted a wonderful, elegant system that's so 99% of that video and rendering code is of course shared between plugins. It's not a lot of effort for me to add new graphics APIs or rendering backends and what have you. And so that's you've got all the niceties, screen effects support, and the shader tool. The shader tool that I originally designed just to auto convert RetroArch post effects and such to my own post effect system has been updated so that it also supports generating shader binary packages for BigPEmu's Direct3D12 backend. And that's a nice way to do things because you can directly convert your GLSL shaders to these Direct3D12 compatible shader binary packages, and you can directly convert any RetroArch post effect or whatever, not just to the GLSL plus DickStack system, but also to the DickStack, which references GLSL and shader binary packages and all that. So that's all nice and automated. And if you have any existing custom GLSL effects that you've written for BigPEmu outside of just converting RetroArch shaders, it makes converting those very easy as well, and supporting all both video backends at once. So I really didn't want to do any kind of shader translation in the runtime. It's a rather disgusting and bloated thing to have to add to a runtime, so it's much nicer to have that be a throwaway tool, basically. And then the runtime just supports the real meat of the data. And those shader binary packages are basically just the DXIL binary plus some custom pre-generated reflection data that BigPEmu uses specifically, which is nicer than the built-in reflection data that is generated by DXC for Direct3D shaders or DirectX shaders or whatever you want to say. It adds a couple things that are lost in that information and makes it a bit more efficient to use at runtime. So there's all that, and then of course miscellaneous features and additions. And for the first time, a real meaningful emulation accuracy change has been made, and that is under the alternate scheduling option. And so this is basically a templated parameter. It turns into a templated parameter for most of the core emulator so that I can basically do all this stuff with no actual runtime, well, no tangible runtime expense, and kind of start unrolling an experimental new timing and accuracy pipeline, basically. And so in the future, that's going to, the umbrella of alternate scheduling, quote unquote, is going to be expanding to include any kind of experimental timing and accuracy improvements that I want to do without having to worry about regression testing over the whole cartridge and CD library, because I can't be asked to do that. And of course, there is actually some automated regression testing that I do, but that's never going to catch everything. So, I definitely want this stuff to be under its own experimental option. But if you are having issues with the game or timing accuracy issues or something, this is a new option that you can try enabling, see if it improves things. It's not going to affect a whole lot for the time being, mostly like some interrupt-related timing and a bit of pipeline timing change will occur when you enable that option. But I don't expect for the most part it's going to matter much. But anyway, it will start to matter more if I continue to work on this stuff without dying. So there's that. Let's see what else we have here. And so to get to the meat of this video, I figured I would kind of demonstrate this new Blitter capture feature, but rather than just showing it happen, which wouldn't be that useful, I figured I would approach a game the way I would if I knew nothing about it and just wanted to capture a frame buffer. Because, of course, in Jaguar land, things aren't quite as simple as they would be with a modern graphics API where you have your capture software and you hit the capture button and it goes, here's your frame buffer resources and all the resources that were used in the frame. No, I'm afraid not. So what you can do here is what I'll usually do is use this op dump command, and that will show you everything that's being referenced by the object processor in a given frame. And so the way the games can display things ranges a fair bit on the Jaguar, but some games will be displaying a whole bunch of different objects with the object processor. Some games will be predominantly updating a single buffer, or sometimes even only a single frame buffer and using the OP for nothing other than just putting that buffer up on the screen once it's ready for display. And Alien vs. Predator here, which I'm going to be demonstrating on, does a little bit of both. So we have the first OP object is, of course, our main frame buffer. And then we have an overlay, the HUD, which is using signed cry colors, which is why it looks weird without actually being correctly blended. And then, of course, the weapon. So, the buffer or the object that we're interested in is, of course, the main frame buffer here. And you can inspect that in Oasis in the data viewer. And in addition to looking over here, you can see the file name specifies both the address of the bitmap object and the bit depth, and of course the dimensions and everything like that, which will be useful if we want to do a blitter capture on that buffer. So you can see here, these are the parameters for the new blitter capture command. So blitcap, and then we're going to go ahead and enter the buffer address, and you can see 320 by 228, and we know it's a 16 buffer. And the way the duration works here is you're basically specifying a duration to capture from the time you enter the command. And you can enter this command while broken in the debugger, or you can just enter it and it'll kind of haphazardly happen whenever, probably between frames. And this time is in actual Jaguar time. So if you wanted to catch all the writes to a given buffer in between or over multiple frames, you can pretty easily do that through this mechanism. Or if a game is, say, running at 20 frames per second, then, and you're capturing from the very start of the time that you're starting to write into this buffer, then 50 milliseconds would be a fine duration. But anyway, so let's say we're for example's sake, we're just gonna do a totally blind capture. We might get it right in the middle of writing to this buffer, or we might catch the tail end of a write to this buffer or something like that. We'll just say 66 milliseconds, and clearing the source buffer can be useful because many games, Alien vs. Predator being one of them, will not clear the buffer in between frames just for performance sake. They don't need to. They expect to rewrite every single pixel in the frame anyway. But for visualizing the writes that are occurring to this buffer, it can be useful to clear it beforehand, so we're going to go ahead and do that. And keep series just means don't increment the capture series with each capture, so it's basically not going to write new data to my hard drive every time I issue this command this way, which I prefer because I'm not actually keeping any of this stuff. Excuse me. Anyway, so let's just issue a blind capture here. Let's see what happens. And as you can see by the black bars here, we did indeed get its mid-frame capture here. So if you want to be very precise about when you start a capture, one thing is you can just kind of like blindly search for the address of the frame buffer in memory. And I've done that here, and as you can see with the live updates, it's actually flipping back and forth between the two addresses of our two different frame buffers. So once you do that, you can get the address of the frame buffer, inspect different code that's using it, and let me see here, set of breakpoints. And so this happens to be one of those places. It's about to copy. This is the frame buffer address we found over here, 2F18. It's about to copy that over to this address here. And so this is a pretty likely, frame boundary type location that you can use. So we have halted here in the debugger. So now we can issue our command again and resume. Oops, don't actually want to keep breaking there, so disable our breakpoint. Oh, oops. I captured on the wrong frame. So, as you can see here, we're actually about to use the other frame. So let's continue. All right, here's the frame we're actually capturing. So now let's try this again. Issue our commands. That's why before you can see no writes were logged, because we were writing to the other frame buffer, of course. So now, here we go. All right, got a hearty amount of writes that time. It's loading up here. And there you go. Looks like we got every single write to the frame buffer as we wanted. So you can also add an optional skip count on the end here. So let's do every 5 frames, or every 5 writes, sorry. Okay. And there you go. So that's how that works. And you can also, as you may have noticed, oops, clumsy motherfucker, actually log the Blitter state with every single write here. And when you do that, you will get a Blitter state which corresponds to each of the write states. And so you can cross-reference, as you're gradually going through the frame, you can say, all right, this is write 259 or whatever, look at the actual Blitter state during that write. And if you are trying to diagnose a problem in your Blitz, that's a pretty damn fast way to narrow it down. It's a lot faster than stepping through Blitter code in the debugger, I can tell you. It's part of what inspired this feature to begin with. I was like, I'm pretty sick of doing this. Why don't I just make a capture feature? So, yeah, there you go. Hopefully some people will find this useful. I could see it being useful for writing your own stuff, but I find it exceptionally useful for just dissecting games and looking at what's going on with a given buffer throughout a frame. And it can even be useful for not even visual data, but logging writes to things like GPU programs and stuff like that. It's basically a Blitter trace feature without having to do something cumbersome like data breakpoint to some piece of memory that the Blitter is writing to, and then do your own logging from the data breakpoint. And so I'm splicing in here because I realized after the fact that I touched on a pretty useful feature which really has nothing to do with this video at all, but the Jaguar game drive fella was recently asking me about debugging a few things because he was using BigPEmu as a reference for getting CD support working on the game drive. And I told him about this, and it's not something that a lot of people think about. You can actually use the breakpoints, the breakpoint conditionals in BigPEmu. So for example, let's say we've got our frame buffer address that we just highlighted here. You can say, okay, it's a conditional breakpoint, just always return 0, So basically, it's never going to break into the debugger. But because the scripting system uh, is being used here, you've got complete access to the whole script API, same functions and C runtime functionality that you would use in a normal script for BigPEmu. You can actually do something like, do a print here. So you can actually print from your conditional breakpoint every time that this memory is read, for example. It will now go ahead and print to the actual log. And this is quite performance, all things considered. It's only actually running this code when a write happens to this location, or a write potentially happens to this location. So, do something like this, and then come over to the log, and there you go. Like every new frame buffer write, we're actually getting, printing the address of the frame buffer. And of course, we can toggle that breakpoint like everything else if we want to stop the spam from it. So, I mean, you can get pretty crazy with this degree of functionality. You can, really, I mean, like, think about it. You can have breakpoints that are conditionally doing all kinds of things, modifying register states and reading and writing memory and logging things. Or hell, I mean, you could write a target file from a data breakpoint if you really wanted to. Like, it's very, very powerful. So this is something a lot of people don't really think about because they're used to conditional breakpoints just having kind of like a simple little expression evaluation type condition, whereas these conditional breakpoints are the actual scripting system, which makes them very powerful. And that's one of the things where some of the Jaguar developers are real like shitty stick in the muds about, oh, I don't like the debugger, I think it's clunky. And like, dude, you are missing, like, you would boost your productivity a lot if you if you would take the time to understand the ins and outs of how the especially powerful functionality works here. Good, because trust me, like, I don't really like the debugger interface myself. It's not like I'm offended when people are like, the interface sucks. I'm like, yeah, but I don't really want to go back and do that interface again. It's 10 years old and I'm lazy. So, but despite the shitty interface, there is a great deal of power within that more than overcomes any cumbersome interface complaints you might have. And of course, if you really wanted to, you could hook in and make your own debugger interface with the hooks that have been provided. But I know nobody's actually going to do that. They may complain that the interface sucks, but they're not going to do any work to fix it. But anyway, completely unrelated to the rest of the video, but I figured this would be a pretty good thing to touch on because, a pretty good thing to go into because I touched on it. Not that I suppose anybody's really going to be watching this video that would benefit from this at this point, but maybe somebody will see it and then somebody will say something and they'll be like, hey, you can do this. And then that person will be saved hours upon hours of their time. You never know. But anyway, my God, my throat hurts like a motherfucker. So I guess I'll leave it at that. And, you know, hopefully I see you guys again before too long. And please enjoy the new release of BigPEmu.